My name is Emily, and I'm going to be talking today about graphing the point of a line and the slope of a line based on the graph and then putting it into an equation. So for instance, if you flip your books to page 7, question 5, you'll see a format that looks like this where they ask you what is the equation for this line on the coordinates of this plane right here, okay? So you're given y equals negative 2x minus 1, y equals negative 2x minus 2, and y equals 2x minus 1, okay? So before we get into that, I know you're really excited to find out how to do it, but two really important central concepts that we're going over right now is finding the anatomy of a point and the anatomy of a line in slope-intercept form. So first of all, a point is always going to look like this, where 3, for instance, is x, and negative 4 is y, okay? So if you look here on this graph, we're looking for 1, 2, 3, and then going down 4 because it's a negative number. So 1, 2, 3, 4. And so this is our point right here, okay? So that's just very basic as far as coordinate geometry is concerned for the ACT math section, okay? And when you're going over the anatomy of a line in slope-intercept form, something that's really important to remember is that y equals mx plus b, okay? So in this example, y equals mx plus b is basically just the slope-intercept form. And m is the slope, and b is the y-intercept. Okay? So while we look at question 5 on page 7, that's going to be really important to remember. First of all, it's really important to think about what do we already know that we're being asked in the question. We're trying to figure out what the equation is given this line, okay? And I've put the coordinates on here for you, so it'll be really helpful to have scratch paper when you're taking the math section of the ACT, because you'll already see this graph here, and you can just count where all the points lie on the graph, okay? And this is going to be already included in the section, as you can see in your book, okay? But since we already know the y-intercept, which is b in the y equals mx plus b part of the equation, you can find that by just looking wherever it lands on the y coordinates, okay? So it's right here, which means it's negative 2. And you can also find that by just counting. Like if this is 1, 2, and this is 1, 2, we're going down 2, so it means it's a negative number, okay? So that means y equals mx plus b. Using that, we know that b is negative 2, okay? Following that, we need to find the slope of the line in order to make our own equation, because all of these are in slope-intercept form for you, okay? So usually, for instance, negative 2x minus y, let's say, means that the slope could be negative 2. However, in order to find that, without looking at these answers even, just looking straight at the line, okay, we can just use slope equals rise over run, okay? And you can find out the slope really easily without any math involved if you just go up, so rise, and then over to the next point. So in this situation with this line, we're going up 2, which means positive 2, and then over 1. And since we're going backwards in the negative direction, it means negative 1. So rise over negative 1, okay? So that basically means 2 divided by negative 1 is what? Negative 2, right, good job. Okay, so that's essentially the same thing as saying slope is negative 2. And now we can just plug in our equation, not even worrying about whatever the options are right now. And we have y equals negative 2, because that's m right here, x plus b. So negative 2 here, okay? And that's essentially the same thing as saying y equals negative 2x minus 2. And we'll look over here at our options, and we have b, and we've solved the problem.